here we go again. Third time's a charm, right? This should be the last one, hopefully. Okay, so I've marked this parallelogram with the first two theorems here, okay? So the next one, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Now that is just parallelogram rules. We should know that already, so we don't even have to talk about that. If a parallelogram has one right angle, then it has four right angles. And again, that kind of is a spin-off of this, that the consecutive ones are supplementary, because if one right angle, the only thing that can be supplementary to a right angle is another right angle. And we just go around the shape. Okay, so hopefully these two are common sense or just things that we already know. Okay. So this one should be pretty easy, right? We're seeing ABCD as a parallelogram. Find the value of each variable. Well, opposite sides are congruent, so that's why 2a gets set equal to 34. And opposite angles are congruent, which is why 8b gets set equal to 112. Okay, so just be careful. They might ask you for variables, they might ask you for actual measurements of angles, so just, you know, or lengths of sides. So if you solve for A, make sure you're not supposed to plug in and double it. If you solve for B, make sure you're not supposed to just add, or I'm sorry, multiply by 8. Okay? Alrighty, so remember, we're assuming these are all parallelograms, I think, okay? If the quad is a parallelogram, and this is the symbol for parallelograms, like that's kind of slanty, slanty rectangle, I guess, if you will. So this one is kind of using a couple different things. You could use that opposites are equal, and you could set 3x equal to 90. You could do so that'll give you x to be 30. You could do consecutive angles are supplementary. So you could also say 4y plus 90 equals 180. Again, if you're using that theorem, you can't set 4y equal to 90. If you're using if a parallelogram has one right angle, then it has four right angles, you know, you could use this idea or the 4y equals 90, which is just what algebra would do in that case. So you have to be careful with which of these theorems that you're actually stating. Okay, so are you stating the conclusion of consecutive angles are supplementary? That's this one. Or are you stating the conclusion that you have a right angle? Okay, because you could write this or you could jump right to this. A couple different ways to handle it. Okay, so y is 22.5 degrees. Number 2, we've got the sides theorem, right? Opposite sides are congruent. So 8y equals 88, and y would be 11. And you could do the opposite angles are congruent, setting 6x equal to 90, or if there's one right angle, there's four right angles, right? So just be careful, because if this isn't stated that it's a right angle, right, you might have to state that first. So anyway, gosh, you're getting silly again. Guys, I don't want to pause it and have to make a fourth video. All right, number 5, you can do a couple things here. Hopefully we're seeing some, remember these are parallel. So if you kind of take out this diagonal here, you've got 2y and 115, right, to be 180, or 2y plus 60 plus 55 equals 180. Now you can get y. Oh, 2y equals, what is it, 65? Yeah, so y is 32.5. And then we know the opposite angles are congruent, so now I can set 65 equal to 5x. and x equals 13. All right. That's kind of all of them. So just, again, reread. Try to, when you're doing these kinds of questions, try to think, okay, which theorem would I be doing here? What would allow me to say 3y equals 12x? What would allow me to say 6x plus 12x equals 180? Right? This is always the, if the quadrilateral is a parallelogram, then you can state any of those 4 things. Okay. Wrapping it up. Here we go. Okay, if the quadrilateral is a parallelogram, we've got 2 other ideas about the diagonals. Okay, diagonals bisect each other, so each of them gets bisected, which means each of them gets split into 2 equal parts. And if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into 2 congruent triangles. So there's really 2 sets here, okay, each diagonal, right? So this AC gives us those 2 triangles, right, AC. And then BD gives us those 2 triangles, okay? And hopefully we are seeing here that we could use vertical angles and we could name 2 pairs of the smaller triangles also created if you're using both diagonals, right? So like side angle side would make these top and bottom triangles congruent, or the left and right angles congruent, or sides, side, 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 you could use too, because remember opposite sides are congruent. So there's lots of ways to prove triangles congruent with these diagonals. Okay, it's pretty much all of, gosh, was that last chapter or chapter 3 maybe? About the parallel lines, or no, gosh, chapter 3, what am I saying? The triangle section. Was that chapter 4? Triangles congruent? I think that was chapter 4. Okay, so bisecting and then also the congruent triangles. So the bisecting is pretty easy. 4y would have to equal 8, so y is 2. 3x would have to equal 12, so x is 4. Okay, hopefully those are pretty easy. So that's the diagonals bisecting. Number 2 is kind of substitution with diagonals bisecting, right? If that's marked with 1 slash, this can be marked with 1 slash. And then if this is marked with 1 slash, this can be marked with 1 slash. So you can set 28 equal to both 2y and 4x. All right, so y would equal 14 and x would equal 7. Okay, diagonals bisecting. Now number 3 doesn't really have diagonals bisecting. We know that, actually I have that we skipped this one, but we have talked about, sorry, I gotta pause. Oh good, came back, okay. Where were we? So you could do some alternate interior angle business here. There is a theorem that talks about what kind of triangles these create, but I don't think we've done it yet, so I don't like this question. We'll ignore it. But this one, okay, so we know we can set 3x equal to 10. To get x, but then to get y, and this is again one of those, I don't think you guys did this much in Algebra 2. SOHCAHTOA. If you don't know SOHCAHTOA, can't really do this one, but even beyond that, something that we're going to really talk about a lot, especially in trig, is 30, 60, 90 triangles. So if that one's 30 and this one is 60, there's a really special comparison of the sides, and one is that this side that's opposite the 60, which would be the longer side, is root 3 times the shorter side, which is opposite the 30. So y equals 10 root 3. And again, we'll come back to that. You would not be expected to know that for the chapter 6 tests, I don't think, unless we do it later in this chapter. I don't know. Stay tuned. Okay, obviously this is not going to come out equally. You can leave it as 10/3 for all I care, okay? Exact answers are always better. That's why I'm not rounding this one. You know, x equals 10/3. That's totally fine. Okay. Here, what kind of angle do we have? Using the converse of the isosceles triangle theorem. We've got an isosceles triangle there. I don't know if that's going to help you, but it does allow you to say that both of these are 3x, so 6x plus 90 has to equal 180. 6x equals 90, so x is 15. Oh, no. I don't know if you guys just heard my daughter, but I gotta pause again. All right, sorry guys, we had a little bit of a 2-year-old bathroom emergency. All right, where were we? Now we gotta get y. Okay, no, we do need to use this converse of the isosceles triangle theorem. So I know that that's 12. So now I have a right triangle where I know 2 of the 3 sides. So we could invoke everybody's favorite mathematician, Pythagoras, and say 12 squared plus 12 squared equals, again, these are bisected, so 2y squared. So here is reaching way back to your algebra skills. This is going to be 144 and 144, so that's what, 288. Squaring 2y is going to give us 4y squared. We don't want to take the square root yet. We want to get rid of this 4. Y squared equals 72. And now we want to square root 72. So hopefully we remember the proper ways to take a square root. Now, whenever you are implementing a square root, you should really have plus or minus. But since this y value is representing a side, the negative doesn't really make sense here, okay? So best way to do these, the quickest way is figure out what perfect square factor goes into 72. What's the biggest perfect square? Hopefully we know 9 is a perfect square, but there's an even bigger one of 36. And you break it into a perfect square factor and a non-perfect square factor. That looks like 27, but this is the root from there. So it's 36 and 2, so it's 6 root 2 is my answer for y. All right, so we're starting to use some of our algebra skills back here. All right. Since we're talking about diagonals here, for coordinate geometry, you're really just doing the midpoint formula. Okay, midpoint formula, remember, is x1 plus x2 over 2, y1 plus y2 over 2. Because it's saying find the intersection of the diagonals. Well, that's just the midpoint of the diagonals, right? They're going to have the same midpoint. So make sure, usually when this is given to you like this, A and C would be diagonals, B and D would be diagonals, because they're all, you only ever name a shape as you go kind of around it. So, I'm just going to label 6 here. A, B, C, D. See how AC becomes a diagonal and BD becomes a diagonal. Okay? So nothing fancy about those. I don't have the answer for 7, but if you wanted to try out 8, you should get negative 2.5 and 0.5. Maybe pause the video, try that out, make sure you can get that. Okay, so let's do this proof. Don't worry, it's going to be short. Statements, reasons, split it up here. Okay, so we have parallelogram ABCD. So I'm going to draw the picture. And it's saying triangle Oh, there was supposed to be a picture here. That's why I'm drawing it. Durr. Okay. The diagonals are drawn in, and they meet at point E. So that was supposed to be in there. Okay, so if we have this parallelogram, that's just given. How can we prove AED is congruent to BEC? Okay. We can say diagonals bisect each other, so we can name AE equal to CE. We can name BE equal to DE, because if parallelogram, then diagonals bisect. Oh my goodness. I'm so sorry. I know the camera was so not on that. Okay. Parallelogram ABCD.
Hey, Mom, can she go?
Your Clarice is in the laundry, honey. Do you want to say hi to the boys?
Yes.
Say hi, boys.
Hi, boys.
Hi, boys. Do your proof. Oh, no, she ran away. Okay, so we've got that equal to that, that equal to that. Do your proof? Is that what you came back to say? Oh, man. AD equals BC. Okay, that's because if parallelogram, opposite sides are congruent. 1, 2, 3, 1, 2, 3. And then we can use side, side, side. Now, if anyone is wondering about, we said AE and CE. A and C are not in the right spot here. So I think I'm going to make this easier on us by not adding in 20 more. I mean, it's possible to still do, but just for our purposes and getting this video shorter, let's do triangle CEB. AEDCEB. Yeah, that's better. And no, you can't just change a problem to make it work in a shorter proof. Only I'm allowed to do that. Okay, so now we have triangle AED. It's congruent to triangle BEC. And if I'm being honest, I looked at my answer key and they mixed up the letters from your version to the answer key version. So that's annoying that I didn't fix it before I copied it for you. All right, how do we like it? We like this chapter of proving triangles congruent, right? So it's all in here. Okay, hopefully all 3 of these you can watch and get through both of those sections. And we're going to give you, I don't know, you'll be watching this, what, Tuesday and Wednesday, so definitely give me until Friday for these 2 assignments together. All right? Find them on MyCC. Let me know if you have questions. Hopefully you did well on your test. And we'll keep rocking and rolling in Chapter 6.